If you are an aspiring data scientist who is still showing basic project in your portfolio, then you are already losing to the competition. RAG-based chatbots are the number one projects that tech recruiters want to see in 2025. And today I'll be building one with only free and open source tools. No OpenAI API cost, no expensive cloud services, just pure technical skills that will separate you from 90% of other candidates. In the next 30 minutes, I'll show you how to build a RAG-based chatbot step by step. Hi folks, my name is Harsh Rawlani. I'm a senior AI scientist and I've been in this field for more than 5 years. In this video, we'll be discussing on how to build a production-grade RAG-based chatbot. We'll start with business requirement, create an architectural diagram, develop the chatbot, and then deploy it. Now, I'm building this project locally and I'm using open source tools as much as possible so that you guys can also download the same models, same databases, and then follow along. Plus, I'll share what are the paid and open source model and databases that are actually used in companies while building this RAG chatbot so that you guys can get an idea on how these projects are built in a real world scenario. So let's get started. Now, let's start with the business requirement. Your team has been approached by a US based bank, and currently they have thousands of customer calls coming in, and all of them are being redirected to customer care agents. They have a team of 100 people who are handling these calls every day. Now, the client wants to reduce the total number of calls that are being sent to the agents, hence, they have reached your team. Now, just to give you a background on this US bank, they already have a rule-based chatbot. But as you must have interacted with a rule-based chatbot before, there are pre-selected options. Just like you can see here, there are pre-selected options between order status, cancel order, and return request. You have to select between them and then chat with the chatbot. But what happens in this case is, in many scenarios, the client's actual query or a problem is not listed in this one of the pre-selected option. Hence, the calls unfortunately gets diverted to the customer agent, and they only have to handle and resolve the query. So that is the main problem statement. That is why the client has approached your team to create an AI powered chatbot where the client can or a user can interact with the natural query and they still get the answers to the questions that they are looking for, so that minimum number of calls are transferred to the customer agent and maximum are handled by this chatbot. So just to give you an example, is what is intended, where the client Joe here has written the query instead of selecting from pre-selected options, has written in its own natural language, and the chatbot actually understands and then revert back to their query. So this is what we are aiming to build today. Now that you have understood the business requirement, let's understand the SOW, where we list down the functional technical requirement, what we are going to develop, the architecture diagram of our solution, and the deliverables. So let's discuss with the statement of work. First, we define the purpose, where our objective is to build an AI chatbot which can handle customer queries, thereby reducing the dependency on customer care agents. Then we list down the background, as we had discussed before. Same thing would come here, where the client current situation is that they have a rule-based chatbot, but it's not able to handle or solve the customer queries. Hence, maximum queries are being transferred to their customer agents, which is the main problem in this case. Then we list down the functional requirement, where in the chatbot a user can write in their natural language. User, if not satisfied, still has an option to redirect their query to the customer agents. They also have a chatbot option to continue from where they left off previously, and a web portal for the customer agents to upload the new documents. So let's discuss this last point. Let's say there is a new promotional scheme going on, or if there is any changes in the eligibility criteria of the personal loan. for which the customer is inquiring about. Now this is the new change which has been brought in, but our AI chatbot has already been built. Let's say while working with a rule-based chatbot, this was not possible directly to be done by the customer agent, because they needed a technical person to add this another option which can give that information to the user. So we have to eliminate that hurdle as well, where the customer agent can directly upload on their own, so that the new user inquires about his new schemes, that can still be handled by the chatbot instead of redirecting those queries to the customer agents. So let's discuss about the technical requirements. That is, chatbot should be trained on the similar documents that customer agent use while resolving the query. The conversation should be logged entirely. There should be an SAP CRM ticket generation process to redirect this query of user from chatbot towards customer agents, and chatbot should be trained on new documents as and when they come. So this is the architecture diagram which I've already built, but don't worry, while developing this chatbot we'll go step by step. So as you can see here, first the user query comes in. It is broken down into the sub queries, and then with the help of AI, and then these subqueries are first vector embedded, stored into a vector database, and then when we retrieve the information based on the user query, that how similar are the documents present in the vector database to this user query, those documents are retrieved, the chunks are re-ranked and then summarized using AI, and then answer is sent to the user. So this is a high level architecture diagram. There will be some nuances that comes in each step. We will discuss that as well. But yeah, this is what the process will look like. Now let's say the user is not satisfied with the answer, then they have an option to connect to a customer agent, where the SAP CRM ticket would be created and the query would be redirected to the customer care agents. Now let's say the customer care agent has resolved the user's query with some additional information which might not have been present in our database. So the customer care agent will record all of this information, create a document of it, and then upload it on the portal, which will again be used by the chatbot. On now the chatbot will be trained on it, and that information would be stored in a vector database, and then so that next time some similar query comes in, the user can be satisfied with the answer directly from the chatbot instead of redirecting it to customer care agents. So that's our goal. Now the architecture diagram for customer care agents, I mean, if you I'll urge you to create on your own, but if you still face a problem, then there is a GitHub repo link with all the code, and as well as the architecture diagram for user workflow, as well as for customer agent document workflow. You can check that out. The link is in the description. So now that we have discussed the architecture diagram, now let's discuss what will be the deliverables, and then we can start with the development process. So as you can see on your screen, the deliverables would be to create a architecture diagram and share the documentation with the client, create a functional chatbot prototype so that they can give their reviews on what should be added, what should be modified or removed, and we can go ahead from there and integrate with their banking system, their databases, create a test case, and UAT sign off should be done, and then we have a post go live support plan as well. That's our deliverables for this. Again, these are the timelines. There would be 2 to 3 weeks required for requirement analysis, solution designing, development. We will be interacting with the existing internal stakeholders for each of these steps so that they are always in the loop and we get a better idea on how to build this chatbot. Now, now that this is out of the way, let's start with the development process. So this is I hope you can see the screen, and this is the PyCharm IDE. First, we will build a workflow for customer agents to upload the documents, and we will upload a sample document, and then we will start with the user workflow. So let's get started with this. So first will be I'm creating a file called store documents. This will be used. Okay, so now we will have any features folder here, which will consist of all the features that are required by this chatbot, and there will be util forward which will be used across the different features, and will be called, and these features will be called on in turn in the store documents and user workflow document. So I'll just create a subdirectory called features, and right now the feature that we need is ingestion.py. This will be used for ingesting the documents. Now I'll create a simple HTML UI for the customer agents to upload these documents. So I'll show that how we will be creating that. We'll be using Fast API for this. So let's start with this import OS from Fast API. Again, all of this code would be present on GitHub. You can refer that for any doubt that you have and to follow along at your own pace. So let's discuss this code. Okay, so these function will help the customer agents to upload the documents. Now this is just a simple HTML code where the user gets an option, or customer agents gets an option to upload the file, and this action is upload the file. There would be a button, and that button will be redirected to this function upload file, where we will first save the uploaded file. What do we do in this? If you go here first we check if the file is actually a PDF one. If yes, then we go ahead, otherwise we report back as an exception that file is not a PDF one. Then we create a destination path. This destination path, since we are storing it locally, so our destination path would be a local folder. Otherwise, in case of a production grade settings, it is actually an S3 bucket where this file actually gets stored, and that is the path used in companies. But since we are doing it locally, so that's why we'll be sending it a local path. So for that, I'll be using config.ini for any query, SQL query, or any hard-coded code that I have to write. I'll be using config.ini for it. So here, right now, what we need is a local destination path. Local destination path. As we discussed, that this path would be the function used to save the file. Destination file path would be locally, where the file would be saved, and then we'll update the query in Postgres. That is, this will include the file name which has been uploaded, user ID, that is the customer agent's ID, and destination path, as well as other configurations would be needed. Again, these configurations are used to connect to the SQL database. So these are the actual three things that will be stored in PostgreSQL. We are using a SQL database here, Postgres, for storing this information. Similar is actually also used in production grade setting. They might be using MySQL or Postgres depending upon their requirements. So now this data ingestion, how this will be routed in this way. As you can see, we have an API router which is called from Fast API. This will by default open this get page, which will be a skeleton UI. As you can see here, this function is being called, and once the user clicks on this upload action, they'll be redirected to this method, which is upload file, where you will save it locally, update the SQL database, and this is the destination folder path which will be passed while calling this data ingestion function in store documents. Now inside store documents, we have created this data ingestion app.include router. Now I've tested this. Let's test again. So now we are testing if our code works. That is what we're expecting. There should be a portal where we can upload a document, and this document gets stored locally into the destination file which we have provided, destination folder that we have provided, and there should be a SQL entry. So yeah, let's go for it. UVCon, what is the module name? Store doc app reload. Let's go. Come on, man. Yeah. Bank loan open. So this is the file. Status uploaded. successfully uploaded. Now let's see, let's execute this. See, there are two entries now. Why are there two entries? I tried the first entry is for the file that I tried already before this video, and the second one is the one that we have just recently uploaded as 12:55 at this point of time. So we have an entry at PostgreSQL. Now let's see this document if this is actually present into the path that we had provided. Reload from disk, Anglon PDF, it's already there. See, this is the sample document which we are using. This has all the information about documents required for personal loan, what are the terms and conditions, and we'll be using this for our vector search. Now we will run this in debug mode and understand what does each step do. Now to do that, I have commented out lines of code where we upload a document. Now instead, since we have already uploaded a document, you can see in the PostgreSQL that we have these entries already present with us. These will be first fetched, then we'll parse this information and read it using unstructured.io. Yeah, let's do that first. So we will fetch this information in MySQL. So I have hard coded these values for our testing purpose, and now we will use this information to fetch the based on the file name that we have provided here in our testing from, and if there is a match present in the PostgreSDB, then that information would be retrieved. So as you can see, we have two data that we have retrieved based on the file name here. We can use any other parameter as well for fetching this information. Now once we have done that, once we have fetched this information, the next step is to parse. Now to parse, we have unstructured.io that is being used. We use unstructured.io for parsing. It is really great open source tool which is also used in companies for parsing PDF, HTML and other documents. If unstructured.io is used along with LangChain, then it provides chunking options as well. There are many methods present when we use unstructured with LangChain for chunking, but as you can see, the PDF that we have, it is one entire or a single block of the text. There is no demarcation present here between the two different paragraphs. Hence we need semantic chunking. In this case, semantic chunking means we identify the meaning of the two consecutive sentences and create chunk based on that. That is, the two consecutive sentences, as long as they have meaning similar to each other and it is above our threshold, we will keep it into a single chunk. Once we have find two sentences where the meaning is less than the threshold that we will be sending, we will break the chunk there and then create a new chunk from that part. But this chunking methodology is not present in unstructured.io when used with LangChain. Hence we will be only using it for parsing, and for chunking we have a chunking model, this one which is being used. It's a great open source model for semantic chunking. Again, in production grade setting, we have text embedding ADA model 2 and 3 which are being used in production grade setting, and they are provided by OpenAI, but they are paid embedding models. Hence we will be not using in this case for chunking or for embedding purposes. Now that we have parsed the document, we will create chunk using the chunking model that we just discussed. So this is first being initialized by Hugging Face. Once the initialization is done, we will call the semantic chunking using this model, and then we will split the documents. So right now we have, unstructured.io again also creates chunk on its own during parsing. That is not based on any semantic similarity or any other methodology. Instead, it's just the amount of token that it can parse in a single document that is being used for creating these different chunks. So right now we have 9 present here, but we will be using this for creating our own chunking. Again, right now what we did in this case is that the chunks that were created by unstructured IO, we used that and created and separated out into multiple chunks using semantic chunker. We could also do that. We can create one single entry with metadata and entire text during parsing, and then use the entire entry to send it to the this semantic chunker. Why we didn't do it in this case is because this open source model has a limitation on document on the amount of data it can parse in one go for creating chunk. And so yeah, that was the main reason for us to pass it in already created chunks. So right now you can see the documents that we have is has 17 chunks present in it, which is based on semantic similarity. As you can see, it has broken the content based on where it thinks the actual similarity reduces between the two consecutive sentences. Now that we have chunked, we will pass it into the documents. Now, next step is to vectorize these documents. So for creating vector embedding, let's see. So we are using this vector embedding model. This is an again open source model from Hugging Face, and we will create vector embeddings from it. As you can see, these are the vector embedding created for the chunk that we have provided, and as we discussed before, these would be the chunk results that this entire thing would be saved for each of the chunk, their vector embeddings, the text as well as their metadata. We do this for all the chunks. Now that we have done this for all the chunks, we will store them in the vector DB. Now this vector DB would be hosted on a Docker container. Why did we use Docker container? Because it is easier to set up the PG vector in Docker container instead of doing a local setup for it. That's the only reason we are doing this. So we remove the vector embeddings from this document, and we store it separately. That is, entire text would be stored in a separate column, and the embeddings would be done in a separate column. We do this for all the cases, and that's where our flow will end. So what did we do here? Just to recap, we first provided a portal where the customer agent will upload the document. We will make an entry of it in Postgres like we have done here. Then we'll fetch the data from the Postgres based on the file name, based on the time that it has been uploaded, or any other parameter that we want. We will parse that using unstructured IO, and once we have parsed that, we will create chunks using a semantic similarity. Why did we use semantic similarity? Because we have an entire documentation in a single block, and there is no demarcation between the two different paragraphs, maybe based on headings or any other way. Since we don't have that, that's why we are using semantic similarity for our chunking. Next, we create vector embeddings of these chunks, and we store or update these vector embeddings into our database. Now in production grade setting, the entire process won't run as soon as a customer agent has uploaded a document. Instead, there would be a scheduler present. So for example, let's say we have a portal where multiple customer agents upload their document as soon as there is some new promotional scheme, or they document how they have resolved a query of user. They upload that, it gets stored into the S3 bucket, and we have an entry into a Postgres. Then maybe bi-weekly or weekly, we have cron job, which is a scheduler in AWS, which runs and chunks reads this document from S3 bucket, chunk them, create vector embedding, and update the vector DB. That's how the process is for customer agent documentation upload. Next, we will look at how the user query used for retrieving the data from VectorDB. Now we will discuss on how to create the user query workflow. The first step in this case is to create a UI. We will be using Streamlit in this case to create a chatbot UI where the user will interact with our RAG-based chatbot and write their query, and that query would be used to fetch the results and respond back to the user. Now again, in production grade setting, you will have a dedicated UI team to do the steps, that is to create the front end of this chatbot where you'll be working on the backend part of it. But since we don't have for this personal project, we'll be using our own basic UI created using Streamlit. Now so this is the code that I've written. First, it's very simple. First is to fetch the user query. We are importing Streamlit and we are fetching the user query where we have the title as chatbot, ask user to enter the query, where user will enter the query, and that query is being passed here, which would be used to send this query to the backend part where we'll fetch the response, and that response would be sent back to the user. Now, since in this initial step we'll be just looking at how this front end looks and how the user interacts, and later on we'll look at how we can generate the response for the query. So now to run this, we will have Streamlit run chatbot.py, which is the module name. You enter that, you have a RAG chatbot demo, you press hi. So this is user and this is bot's response. You can see here we are printing both the cases, query and response. So this would be the front end that we'll be using. Now let's go to the next step where we will discuss on how to respond to the user. So next step is to respond to the query. Now the first step in that case is to rephrase the user query. Now, why do we need to rephrase the query? So let's say user has asked a question like, now can you tell me about personal loan? Now in that case, this is very generic query, and we'll fetch the result which will give the user information about what is a personal loan, what are the different types of personal loan, what is the rate of interest of each of these types, what is the eligibility criteria, etc. So this might contain useful information which user is actually looking for, but it also contains a lot of irrelevant information which user might not be looking for. So in that case, we need a user query rephrasal. That is, we will change the user query using LLM. There are various methods of rephrasing the user query. So there is decomposition where we use singular keywords, and based on those keywords, we create an entire query, and then that is also being sent along with user query to fetch the result. There is context enrichment kind of user query rephrasal where we improve the context of the user query before we send it for the retrieval, so that the information that we get comprehensively covers all the aspects, and that is being sent back to the user. And this way there are multiple types of rephrasal. You can see that on your screen. Now to do that, we have LLM to rephrase the query. Again, we are using an open source LLM here. So the LLM that we are using is, so there are 4 to 5 types of different LLMs that we have found that can be used in this case. Mistral is one of the best and open source model that could be used, but it has 7 billion parameters, hence is very resource intensive. So if you have that capacity and if you want to go for a best open source model, I'll recommend you to go for Mistral model. In this case, for this project, we'll be going ahead with Microsoft model. So it has decent accuracy, but it has less number of parameters, hence it's not that resource intensive as Mistral, and still provides better results compared to other models. So we'll be using Microsoft model for query rephrasal. Query rephrasal have tokenizer, so we again initialize the model and then we pass a system query along with user query and get the results. That's the idea here. So now this is where we initialize the model. We provide the different parameters for the tokens, and after that, once we have initialized it, then we pass all the input parameters that are needed, and once that is done, we generate the output, and then that's how we get the rephrased query. Now I'll just show you how this will work. So let's say our query is tell me more about personal loan. Now this is the generic query. Our intention is to rephrase it to provide more context by creating subqueries. Okay, so we'll run it in debug mode. So this is the query. You can see we'll print the query, and now we'll go for rephrasal. To do that, we have to first log into Hugging Face. So you have to create an account on Hugging Face. You'll get a token ID. Use that information, store it into config.ini, and then use it for logging in. Rephrase the query. We will start tokenizer, pass this information. So now what this will do is this will download the model first, and then so that you can use it in your local machine. Once that is done, we'll generate a prompt. It's just combining the system prompt along with the user query. We'll see that how it is done. So we have written a very basic prompt where we say that you are a prompt engineer, you have been given a query, you have to return 3 rephrased queries based on the keywords provided, and this is the output structure, and you should follow only this output structure. And yeah, and then this is the query. We should provide a separate, yeah, this way we should provide user query. Let's go to the point, and now we will rerun this, and then we'll go to the next step. This will take some time to respond back. Again, this has a lot of parameters, hence it's resource intensive, not as resource intensive as Mistral, but since we are running it locally, that's why it is taking time. In production grade setting, all of these models are either hosted on a separate EC2 instance so that it is easier to call them with lower latency, or we use a paid LLM, for example GPT 4.0, Claude 3.5. so you make an API call, get the response from them, and they have a really good accuracy compared to these open source models. So that is what we used in production grade setting. Next step in this case, once we get a rephrase query from the LLM, so what I've seen in case of open source model is that they respond back with the query as well as the response to that query. So we have to extract the response from this output. To do that, it's just a simple cleaning process where we look at the last closing bracket and the last open bracket, and once we have that, we create a string. Once we have that JSON string, we just load it as a JSON and then respond back. So that will be our clean query. Then the next step, once we have this subqueries with us, we will just pass all of these queries into a single list to our next step. So to do that, we have all the subquery dictionary. That is a JSON output that we have returned from, that we got from the Microsoft model, open source model. We have our user query. We just append it to a single query list, and then we go to the next step. Now, next step in this case is once we have the list of all the queries, that is the subqueries we have created from LLM plus the user query, we fetch the response from the vector database. Now, to do that, we first have to create vector embeddings of it and then fetch the results. Now, to do that, we have this function. What we do here is we first initialize the vector embedding model. Now make sure this vector embedding model is the same vector embedding model that you have used for storing your documents. If it is different, then you will get empty results. So once you have a vector embedding model initialized, again for initialization is the same way, we have Hugging Face model. So once you have initialized this vector embedding from your subqueries, next step is to embed the user query for each of the subqueries that you have created, normalize it, and then connect to the vector database. Get the top similar documents. That is, for using the vector embeddings of the query, send us to the vector embedding, send us to the vector database, fetch the results which have similar embeddings to our user query. Fetch two results, as you can see, k is equals to 2. Now once you have these documents fetched, it could happen that these documents are from two different paragraphs and are unrelated to each other directly. They are related to the user query, but they don't make sense cohesively as a one single answer. So in that case, we will again use LLM to where we will send all these user queries and then create a singular answer for each of the subqueries. So once we have this similar documents created, again the LLM that we use in this case has a token limit. That's why we are only passing, that's why we are chunking this result that we have fetched and then passing it to the next step. We use BART in this case to summarize the result. That is to use two different paragraphs that we have fetched here from this user subquery. And then create a summarized result for each of the subqueries. So what we do here is we just check if it exceeds the maximum length that we have provided, and if yes, then we strip at that point and then we go to the next step. We check if it is higher than 900, which is what we have used. Then we take the first 900 as prompt. It includes system prompt as well as the documents that we have fetched. Then we initialize this LLM model and then we pass this input parameters to it and then just we wait for the response. So we do that for each of these subqueries until we get results, one single result for each subqueries. After that, the next step is to summarize. Again, to summarize, we can use either Microsoft model or we can use BART. So the process is same. That is, we pass user query as question and all the response that we have received from each of these subquery results as the answer. That is answer 1 of subquery answer, which is the answer to subquery 1, answer 2, which is the answer to subquery 2. Similarly, for all the subqueries, with the question being the user query. Once we have pre-processed that, we initialize the model and then we call the model, ask it to summarize all the answers into one and then respond back. This summary that we have received is then passed to Chatbot as a response, which we send it to the user. And that's where our process gets completed. Now let's see this in action. Okay, so now that this front end is open, we will ask our query, which is, can you tell me documentations required for personal loan? Enter. Yeah, so as we have seen, the query that we have passed is what are the documents required for personal loan. So I'll show you each step, what is the output of each step and what would be the final output in this case. Okay, the first step that we'll see is rephrase user query. So in this case, what we are trying to achieve is to improve the context of the query that is being asked by the user so that we can get better results, and that could be passed to the LLM and then summarize the final results and send back to the user. So as you can see, this includes the first query that user has asked, which is what are the documents required. Then we have some rephrase query, that is a list of documentation for assessing personal loan eligibility, necessary paperwork, how to apply for documents needed to apply for personal loan. Then we fetch results for each of these queries. That is, we first find the similar documents, send those answer documents to the LLM, and create a summarized result for each of the subqueries, and then send back as a final result. So these are the answer that we have got. One is this includes the documentation that is required in first case, and second one includes the rest of the documents. It's not opening. Okay, so as you can see, appointment letter and confirmation letter of a workplace ID, salary certificate, etc. And for all other documents as well, we got the same answer. Now we will send this for summarization. That is, create one single answer from all these answers of subqueries. Yeah, so let's go to the last part, which is the summary. So as you can see, these are the two response that we have received for our query list. And yeah, once we summarize, so we call Microsoft model here and get the summary. I've done that and I've received the summary, which is this. So these are the documentation required for getting a personal loan. And so this is the response that we send back to the user. So this marks the end of this tutorial. I hope with this project you'll be one step closer to your dream of becoming a data scientist. As you know, the demand for the employees with skills in AI and data science is going to double in the next few years. The salaries offered to even entry-level role is 50% higher than any other software development role. And with this demand in jobs and higher salaries comes the supply of people with AI skills. So if you want to stand out, you need to know exactly which tools and technologies to learn. And to learn that, watch this video on your screen.